So before I start my presentation, is there anybody who'd like to ask any questions, anything that they're interested in learning about when it comes to blockchain and DevOps? I can answer any questions if you let me know if you're interested in learning about something. I can perhaps speak to that. If not, I'll just go ahead and start the presentation. So I'll share my screen. Yeah, so let's see, where's the screen share here? Details, attachments. Okay, so I'm gonna share my screen now. Okay, everybody can see my screen, right? So we'll get right into it. Yeah, so blockchain and DevOps. I mean, today we're going to talk about smart contracts and DevOps. So this presentation will give an overview of smart contracts and how they mesh together with DevOps. We're not going to explain everything about DevOps because some of that has been covered in other sessions. And we'll explain how smart contracts can fit into DevOps pipelines and how DevOps can be used for smart contract development. So those two things. I'll be referencing mostly Ethereum, but the principles that I talk about can be applied to all blockchains. So Web3 I'm going to just do a brief overview of a concept called Web3. Web3 is kind of like a next generation of internet apps. So in Web 2, you have a front end that connects through HTTP request, connects to the internet to a web server, and then the web server just does API calls to application servers and databases. So it just goes from your front end to web servers and web servers to the back end. But in Web 3, you add an extra layer, which is sort of like a layer that's owned by the user. So the app not only communicates with the server, but also communicates with the user's wallet, which can hold digital assets, including cryptocurrencies and other types of assets. And the wallet, there's kind of like a parallel layer to the server where the app connects with the server, but the wallet connects with the blockchain server. So the app doesn't have direct access to the wallet. The wallet is controlled by the user, and the user has to give permission to the app in order to use it. So basically, Web3 is about distribution of control, and important information can be held by the client, and the websites can only access the client's information with the client's permission. So it puts a lot more into the control of the user, who's able to control their information, control their assets, their money, and basically the app needs to get permission from the user. So you can think of it, instead of users logging into websites, into servers, or into apps, now the app has to log into the user because the app has to get permission from the user to do anything. And of course, with the blockchain, it opens up a whole new host of possibilities, like smart contracts and digital transfers of value. So we'll just go on to the next slide. So now we'll start talking about DevOps again. We're going to talk about DevOps, how to use DevOps for smart contracts, and how to use smart contract for DevOps. So DevOps for smart contracts is already something that people have started doing, and they use DevOps to automate smart contract building and create secure life cycles, so that they can create smart contracts in a safe way. The thing you have to realize about smart contracts is that, like, if smart contracts can hold a lot of value inside them, a lot of digital currency, so they have to be very secure. If you have a little bug in the smart contract, you can lose a lot of value. There's examples of millions of dollars lost already on bad smart contracts that had bugs in them that were hacked. So the funds are only secure as the quality of the smart contract. That's why DevOps automation and having secure automated life cycles is very important. Because it will reduce the risk of flaws in the smart contract and make it much safer to put lots of value onto it. And also, it's important to be able to reproduce smart contracts and reuse the same secure code over and over again. So DevOps definitely comes in handy, and we'll go over DevOps tools that people are using to automate smart contract programming. Yeah, so I mean, this is just a regular DevOps application development lifecycle. I put it here just to remind people how DevOps goes. You just code, you make a plan, there's a monitoring process, you have to deploy it, and then continuously release new upgrades, and then test it, and then build it, and then go back around over and over again. So I just want to talk about how smart contracts can be used for DevOps. So before I talked about how DevOps can be used for smart contracts, but now this is a very novel approach to DevOps, to use smart contracts to help in the DevOps process. So smart contracts are basically code that is put on the blockchain and that can be executed. And when you put something on a blockchain, it's immutable. Immutable means that it can't be changed, it can't be tampered with. So when you put a smart contract on the blockchain and you have a certain piece of code that's running, you know that it's going to run like that every single time, and there's nobody who can change it. Whether it's good code or bad code is a separate question. It could be good code, it could be bad code. Hopefully it's good code, but it will run the same way every single time, and there's nothing anybody can do. There's nothing that anybody can do to change it. The only way to change it would be to break the blockchain itself, but that's a whole other can of worms, and that would require breaking battle-tested cryptography and consensus mechanisms, the underpinnings of the blockchain, and that's not something that you have to worry about as a smart contract developer. So what can smart contracts do for DevOps? Smart contracts can enforce permissions of the dev team and the operations team. So one thing smart contracts are very good at is managing permissions. If we go back to this diagram here, you see that there's the wallet, a key component of decentralized apps. So if you imagine that the developer team and the operations teams the members hold their own wallet, what that means is that they can sign off on things like new releases. So you can program a smart contract to give people permission, to give the team members permission to sign off on new releases. And this will really provide transparency across the organization as to who's actually responsible for signing off on new releases. So you need, yeah, you can program a smart contract to you can program it to only release the new upgrade when certain people sign off on it. You can enforce the permissions in the smart contract, and it makes things super transparent and super predictable. So another thing you can do is enforce upgrade conditions. So you can say in the smart contract that these tests need to be passed before the new upgrade is released, for example. You can also automatically enforce service level agreements. So if the app doesn't adhere to certain conditions, if a new release is broken, and let's say we have a customer agreement where if the release doesn't deliver as promised, then the customer can get a refund. That could be programmed directly into the smart contract, and as soon as the release is proven not to work, then the customer will automatically get a refund. So all kinds of agreements that you have and service level agreements can be automatically enforced. So when you're talking about smart contracts, you can think of them as self-enforcing contracts. So it's like a legal contract. Is one way of thinking of it is smart contracts are like a legal contract that automatically enforce themselves. So if you have, let's say, some money in there, it could be automatically distributed to customers once the release fails, if that was part of the agreement. So it basically provides a lot of transparency to everybody, including the developer team, the operations team, the customers, all kinds of stakeholders. And for all these above reasons, smart contracts could make DevOps pipelines more reliable. And it could also decentralize decision-making across the various levels of the organization. So, yeah, the thing about this is there are a lot of clear benefits to using smart contracts in the DevOps pipeline, but there's not really anybody doing this yet. So this is a very novel. It's still theoretical, but I would argue that it's only a matter of time until people start using it, and the benefits are so clear that many companies could benefit from using smart contracts right away in their DevOps pipeline. And I hope to convey that in this presentation. So yeah, I mean, if anyone has questions, you can go ahead and ask. I'm happy to answer questions about the presentation. So does anyone have any questions? If not, I'll move on. Okay. So does everyone understand everything so far? Is there anything that's not clear? Is there anything that's confusing? Is there anybody who needs an explanation on some of the key concepts of smart contracts, or an explanation on the basics. Okay, so here's now we talked about how to use smart contracts for DevOps. We're going to go back to talking about how to use DevOps for smart contracts again. So basically, DevOps can be applied to smart contract development, much like DevOps, how DevOps can be applied to any other sort of development. So you have this thing called upgradable smart contracts. One thing about smart contracts is that they're immutable. As I mentioned before, you cannot change a smart contract after it has been deployed to the blockchain. So there's some people who came up with the concept of upgradable contracts, which is basically a system of smart contracts where you can swap certain contracts out for other ones. So then it creates a sort of upgradable system of smart contracts, even though once you deploy individual contracts, the individual contracts cannot be changed. You can still upgrade a system by swapping out individual contracts. So also very important is smart contract governance. When you deploy contracts, sometimes there are owners of the contract who have certain capabilities, such as changing fees or updating permissions of various kinds. So governance is very important. At the most basic, you have one owner who holds one address, which is based on one private key. So that can be problematic if that user loses the private key, or if the private key gets hacked, then the whole smart contract could be compromised. But if you have a team of people with a group of private keys, and say you need 2 out of 3 in order to pass the permissions, or 3 out of 5, that's called multi-sig. And that's a lot more secure than having just one owner. So that governance comes in where you have multiple people governing permissions over a smart contract. And that's also an evolving science and an evolving art. So DevOps again, performing testing on test networks and unit testing on smart contracts. Testing is absolutely critical when it comes to smart contracts, even more so than regular programming, because, like I said before, a single tiny bug in a smart contract can lead to millions of dollars lost. That has happened, and you don't want it to happen to you. So test all day, every day. Make sure you test everything. Unit testing is very useful for smart contracts, and it has been proven to be extremely useful. You test little things one at a time. And most professional smart contract developers swear by unit testing. And when I say professional smart contract developers, that's really a loose term, because smart contract programming has only existed for about 4 years at the most. So this is very new and cutting edge. Again, the newness of smart contracts explains why they aren't regularly used in DevOps, even though you have all of these amazing benefits. So yeah, it's only a matter of time before smart contracts are used in DevOps. And if you learn how to use smart contracts now for DevOps, you'll be way ahead of the curve. And I mean way ahead of the curve, because almost nobody's doing it right now. I mean, I tried to find examples on the internet, but couldn't really find much. So yeah, it's really cutting edge stuff. And there's really a big disparity between how useful it is and how little people are using it right now. So it's a very, very high growth area in my mind. Okay, and yeah, so smart contract permissions and governance, very important. You can use upgradable contracts for continuous delivery. There's tools for that. And yeah, because it's much easier to do continuous delivery and continuous integration with upgradable smart contracts than it is with non-upgradable smart contracts. And the reasons for that is, okay, we'll go to the next slide. I'll get into the reasons for that in a second. But here are some very awesome tools for, yeah, my screen's still showing, right? Yeah. So some awesome tools that you can use to do DevOps on blockchain. Truffle is probably the most popular blockchain development toolset. It's used for Ethereum, but it can be used for other, they call them EVM compatible blockchains. That means Ethereum virtual machine compatible blockchains, essentially blockchains that are similar to Ethereum. So Truffle, I can show you a little bit about that. You can just go to Truffle. TruffleSuite.com, and they have tutorials on there, and yeah, it takes some getting used to, but once you get used to it, it's not actually that difficult to use. So you can use Truffle to deploy smart contracts, to interact with smart contracts, and so on. So what you would do is you would write a smart contract in Solidity, and then use Truffle to deploy it and interact with it. Truffle comes with some different so-called suites. One called Ganache, which will run a local test blockchain for you, so you don't have to deploy it on the Ethereum mainnet. And by the way, for those of you who don't know, when you do transactions on the Ethereum mainnet, you have to pay Ether as a transaction fee, and that costs a lot of money. So when you're testing, you do not want to use the mainnet. You want to use testnets, either public testnets or local blockchain. So a local blockchain is basically a test blockchain that runs on your computer. And a public testnet is a testnet that you can use for free that's accessible on the internet to everybody. So that's Ganache, and lets you run a local test blockchain. Then there's Drizzle, which helps front-end devs connect to your smart contracts. You can see here, Drizzle is a collection of front-end libraries that makes writing dApp front-ends easier and more predictable. And Ganache, a personal blockchain for the Ethereum development you can use to deploy contracts, develop your applications, and run tests. Sorry, I'm just going to get a drink of water. I'll be back in a second. Sorry about that. So yeah, Truffle is the most popular tool to work on Ethereum. The most popular blockchain development toolset there is, I believe. And I recommend using it. There's also, yeah, so Truffle actually has a lot of DevOps capabilities. Like there's automated testing. I'll go into it in a second. But there's also Open Zeppelin command line interface, Open Zeppelin CLI. It's very, very useful tool that lets you develop, deploy, and operate upgradable smart contract projects. So if you want to do upgradable smart contracts, this is the tool to use. And again, upgradable smart contracts are very important for DevOps because it lets you release new upgrades to your smart contracts way more easily. And then there's another tool here called builder.dev. It's just an intentional misspelling of builder. With kind of a crypto meme. And builder.dev works together with other tools and has excellent logging and testing features. You can use builder.dev and use other, you can use Truffle and OpenZeppelin together and integrate it all in here. A little bit more difficult to use, but very useful once you get the hang of it. These two tools are from Argentina. They're developing a lot of cool tools over there. Truffle is from America. So we're just gonna look at, here's a screenshot from Truffle. So there's a lot of stuff you can use for DevOps here. It organizes it very nicely. You can build, smart contracts, you can deploy smart contracts, you can manage them, you can track all of the changes. Yeah, you can do a lot of stuff. You can monitor all the activity in the smart contracts. This thing is called Truffle Teams. It's it's pretty new. I haven't really delved into it too much, but it seems to be very useful and has a lot of capabilities for blockchain development. And it's definitely going to be useful from a DevOps point of view because it lets you track changes in a way that's really hard to do otherwise. Yeah, so yeah, and it lets you manage a lot of contracts simultaneously. That's another thing. You want to do a project that has lots of smart contracts, Truffle is good to use. So if you're managing a big team, they're all developing different smart contracts, you can use Truffle to keep track of all of that. Pretty much the best tool out there right now. Oh, and by the way, I mentioned this before, but I'll say it again. This is all for Ethereum smart contract development. Ethereum smart contracts are written in a programming language called Solidity. There's some other minor programming languages people can use as well, like Viper and LLL. But Solidity is far and away the main language that people use to write smart contracts in Ethereum. Truffle will also work in other blockchains as well, if they're compatible. Most of them are what's known as EVM compatible, or compatible with the Ethereum virtual machine. So people who develop blockchains that are sort of inspired by Ethereum, you can use Truffle for that too. Okay. So, yeah, let's see. Yeah, I just want to mention that, I'll just say it again, that smart contracts can replace traditional tools within the software pipeline to identify issues with continuous integration, for example. Information on smart contracts is public, so it can be independently and automatically verified. And if there's an issue at any point in the pipeline, the smart contract can require that it be fixed or at least addressed before it moves further down the pipeline and becomes a bigger issue. So you could just program the smart contract to verify each step, and if there's a problem at a certain step, it won't let the process move to the next step. And that can prevent bigger issues from happening over time, because it'll force the team to fix small issues as they come up. So that's a very exciting possibility as well. And oh yes, when it comes to transparency as well, and service level agreements, smart contracts can make sure that users have a guarantee that the application's failure to provide certain functionality would be detected automatically. So automatic detection of the breach of service level agreements. But that's very good for transparency and very good for users as well. And that would give them a lot more confidence in the app. So yeah, I mean, there's, like I said, so many benefits. I said it before, but it's worth saying again. Smart contracts can definitely improve the DevOps pipelines. It's only a matter of time before they start getting integrated. So if you're looking for something to learn, this is, and you're interested in DevOps, this is a very good approach. So now we're going to talk a little bit more about upgradable contracts. As I said earlier, smart contracts are immutable, meaning that once you deploy it, that's it. You can't change it. It's done. That can be a blessing and a curse. It means that people can trust that it can never be changed ever. But on the flip side, if there's a bug, there's an error, if it's not what you wanted, you want to change the rules, you might have to deploy a new contract. So the thing is, if your contract is not a part of an upgradable system, it's just a standalone contract, this is what you would have to do to deploy a new version of the contract. First, you have to deploy the new contract. Second, you have to manually migrate all the state from the old contract to the new one. State is just a technical term for all of the values in the smart contract. So it could be the balances of a digital currency, it could be user information, it could be IDs, it could be, so state it just means all of the information that's stored in the contract, all the variables and the values of those variables. So you'd have to manually move the state from the old contract to the new one, which could be very expensive in terms of gas fees. So that can be very prohibitive. Third, you'd have to update all the contracts that interacted with the old contract to use the address of the new one. So for those of you who don't know, smart contracts have addresses, just like users do. On Ethereum, there's two types of addresses. There's accounts and contracts. Accounts is what people use. So you and I have accounts. For example, here's a wallet that I have in my browser. Just a quick note. Let me go back to this. If some of you were confused about what this wallet means, here's an example of that right now. This is called MetaMask. MetaMask is a browser extension, and it's also a wallet that holds funds, and it holds Ethereum addresses and secret keys, which prove that I own this address. So each address has a private key behind it. The private key is what's secret to me, and so this address has a private key behind it that only I know, and only I can sign transactions and move the money out of this address. So that's what this wallet is this wallet is an example of this wallet is MetaMask. So I can use this to sign transactions and interact with front ends that are, or Web3 front ends, or as we call them, decentralized apps. So let's go back to Upgradable Contracts. Basically, updating standalone contracts is a very tricky process. You have to change all the states. You have to upgrade all the contracts that interacted with the old contracts. And you have to reach out to all your users and convince them to start using the new deployment. So you can imagine if all your users are used to using one smart contract and suddenly you say, oh, you have to use this one, you might lose a whole bunch of users, right? Potentially. So the solution to that is making smart contracts, putting them in a upgradable framework. And how does that work? Basically, you create what's called a proxy smart contract and an implementation smart contract. So proxy, it's French for close. It's not actually French, it's Latin. It's Latin for close. So that's the contract that's close to you that you interact with, and the information. So the one that the one that never changes. So this contract can store all the contract state, all of the values, all of the user balances of currency, identification, user personal information, whatever it is, data of any kind. And the implementation stores the contract logic. So the real trick to upgradable smart contract is to decouple the state and the logic into separate contracts. You have one contract for the state, one contract for the logic. You deploy a proxy contract for state and a delegate contract for logic. Delegate is, in this case, we call it implementation. So an implementation contract for logic. And what that means is that you can upgrade the logic contract while the proxy contract retains the balance, state, and contract address. So now, if you have a bug in the logic, you can just change the logic without changing the state, and without changing the contract address that everybody's interacting with. So in practice, this is kind of difficult to do, except as I will show you, this opens up Flynn CLI, command line interface, actually makes it very easy. So if you want to build upgradable contracts, just use this. So yeah, how does it work? You have your proxy, and then you just deploy a new implementation, and then just add that to your proxy, and you get rid of the old one becomes obsolete. So you just updated your logic right there. Yeah. So next, I have a demo for you guys. But I'm wondering if there's anybody who has questions. Anybody who would like to say anything, or any comments of any kind. So that'd be nice to, if anybody has any feedback. Don't be afraid to ask really basic questions. I don't know what level of expertise everyone has, but if you want to know really basic things, please feel free to ask that too. Is there anybody who'd like to ask anything? No, you can type questions in the chat too. Hold on, let's see. Actually, let me check the chat. Yeah, are we sure? Like, does everybody understand everything perfectly? I guess everybody has perfect understanding. No, I'm kidding. Don't worry. All right, so so in this demo, I will show everybody how to deploy upgradable smart contracts. First, I'm going to do it the hard way, and then I'm going to do it the easy way, just to show you what's going on. So, yeah, you guys all see my screen, right? Okay. Okay. So now we're just going to go into the browser. Here is another tool. It's not very good for DevOps, but it's good for simple testing. It's called Remix. It's online browser IDE, or integrated development environment. You basically write your smart contract here and deploy it through here. It connects to MetaMask, so you can deploy it on the blockchain using MetaMask. So I'm just gonna go through this this little tutorial here. I want to learn how to write upgradable smart contracts. So on this tutorial, how to write upgradable smart contracts in Solidity. So yeah, basically it's saying you know, code might not be secure. You know, it might not be optimal. You might want to upgrade it to prevent damage by bugs and things like that. So, like I said before, you want to separate the logic and the data. It says a lot of things. I've explained most of it in the previous presentation, but basically, there is some code on GitHub here, and that has all the code for upgradable smart contracts. So we're just going to take that code. I already cloned the repository, and we're just going to import it into Remix. So for anyone that doesn't know, you can just clone repositories on GitHub and copy all the code to your computer. I've already done that. I'm going to open up all the contracts here. So remember how we said we had a proxy contract and an implementation contract? In this case, it's called proxy contract and delegate contract. The proxy contract is the one that doesn't change. It's the static one. The contract address never changes. The state never changes. So whenever you store new variables in the contract, it'll be stored inside this contract. So basically, there's some code here. What is it? Key value storage. This will.
Can you increase the font size?
Oh yeah, yeah.
Thanks.
This contract will so by the way, this is Solidity code. Don't worry if you don't understand everything. I'm just going to explain the main principles. Because this is not a basic Solidity coding workshop. If you need a basic Solidity coding workshop, I'm happy to provide that too. But this contract will let you store values of different types. So just imagine you can store any strings, any integers, any Boolean values that you want. The proxy contract inherits the key value storage. So basically, the proxy contract is able to store state. So what we can do is just deploy the proxy contract. So you can just go ahead and do that. Compile it and deploy it. I'm not really explaining how to use Remix now. I'm just kind of showing you an example of how it works. Actually, first we have to deploy this stored state contract. Sorry, Proxy doesn't inherit it directly. It's using it as a reference. So yeah, just a side note, when you deploy contracts, MetaMask has to give permission to the app to do anything. So the app told MetaMask, oh, I want to send this transaction to the blockchain. And MetaMask is like, okay, I'm going to ask my owner for permission. So I got asked for permission, and I'm going to confirm it. We're actually using a public testnet. It's a public testnet called Solidity, and it's a free testnet anybody can use and anybody can read. Doesn't have any value on it. It's just there for testing and experimentation. It doesn't have value on it like the main Ethereum network. So yeah, okay. So I deployed the storage state contract. Now I have to go deploy the proxy. So deploy the proxy here. And the storage state contract is this one here. Each contract has a contract address. So what you see here is a contract address. This is an example of a contract address. And I'm also going to put my address as the owner of the contract. So this contract, in particular contract, has one owner, which is me. So let's deploy that. Okay. Right, deploy the right one. Storage state, key value storage. Oh. Maybe I need key value storage. Anyways, the point I'm actually trying to make here is that it can be very tricky to to deploy upgradable contracts. So this is really playing into my favor. In a second, I'll show you a simple way. But let me just try and mess around with this a little bit because we have the time. If anyone has any questions, go ahead and ask me. But yeah, I'm just going to try and get this to work. If it doesn't work, that's okay. I'm just trying to show you how hard it is. So yeah, key value storage. So you have to do a whole bunch of stuff, deploy contracts on top of contracts. Proxy, storage. Put the storage here. This here. Nope. Yeah, I'm not sure what you want. All right, well, it's not working, but that's okay. Well, basically what's supposed to happen is I deploy the proxy. That's the unchanging contract that doesn't change. And then when I want to update the logic, here are the logic contracts. So if here's a logic contract that says you can set the number of owners and get the number of owners. And let's say you want to change the logic, well, you're just going to upgrade it to this one, right? You have it, which has more functions. So you can increase the number of the functionality of the logic and add more functions and things like that. You change the logic. So what happens is when I call this proxy contract, the proxy contract will use the logic from these contracts, but it will execute all the logic as if it was executing it inside this the proxy contract. So yeah, that might seem a little bit complicated. If you're not familiar with smart contracts, it's okay if you don't understand. You should read and practice basic smart contracts first, and then you can understand more about upgradable smart contracts after that. So yeah, basically I'm trying to show you how tricky it is to do. But now let's check out the Open Zeppelin CLI. So they have a really great tutorial here. I recommend anybody who wants to learn about smart contracts to go to this docs.openzeppelin.com/learn and do all of this. It might only take you a day, might take you less. But if you do this, you'll have a really good ability to deploy smart contracts. This is really kind of a DevOps tutorial, which doesn't focus on how to write smart contracts. It focuses on how to deploy and interact with smart contracts, and especially deploy, and write automated tests, and how to upgrade smart contracts. So what I did was I went through this entire tutorial. I won't show you every single step, but I basically wrote this smart contract over here in Atom, right? So I have a smart contract here. You can read the code a little bit. What does it do? I just have declared an integer value here, and then there's two functions: store and retrieve. Store basically writes a value to this variable, and retrieve gets the value. So this is just set and get functions. Just reading and writing from the blockchain. So that's all this contract really does. This function writes, this function reads. Hope that's understandable. And so let's say we want to deploy the smart contract. So I already installed all of these things. If you want to do it yourself, you have to install them with the npm. So yeah, we can do a bunch of things. So we can check out which addresses we own, npx, odds, accounts. I'm just going to show you a few things here and there. Okay, npx, odds, accounts. So it's going to ask me if I want to look at Goerli or my. I'm actually running a test blockchain with Ganache over here. Over here. This is what it looks like when you run a test blockchain with Ganache. It's just a bunch of gibberish if you don't know what it is. But it's actually a fully simulated blockchain which you can practice on and deploy smart contracts and do Ethereum transactions and all kinds of stuff like that. So right now, all I'm doing is I'm asking it what are the accounts that I own. Right now, I'm not using a test blockchain. Actually, I'm using the public testnet, Goerli, which means that anybody can actually go on to Goerli.etherscan.io. This is fully public for anybody on the internet, and they can look at the address that I'm playing around with and seeing all the smart contracts that I'm deploying on the testnet. So it's like a shared blockchain anybody can interact with and practice with for free. So I just looked at my accounts. I can look at the balance of a particular address, that kind of stuff. But here's the part we're really interested in. Well, let me just demonstrate this just so I can, it's good for you guys to see. So balance, I got to put in an address to query its balance. Well, let's put in my address. This is my address up here. So I actually sent myself 2 Ether a while ago. This is 2 Ether, but the thing is Ether has 18 decimal points. So yeah, it says Ether is 1.97F. Or this is the balance in Wei. So Ether can be divided into Wei. There's 10 to the power of 18 Wei inside 1 Ether. That's why you see so many zeros. If you have 1 Ether, it's 1 with 18 zeros. So, okay, I just saw my balance, saw my addresses. This is all on the Open Zeppelin command line interface, by the way. So next, I took my contract. Previously, I had initiated like a project with Open Zeppelin command line interface that built out all of these directories for me. But I'm just going to show you the deployment and the upgrades. So here's a way to deploy smart contracts. Here. All you have to do is make sure that you have your contract inside the contracts folder, right? So I have a contract called box.sol, and it's inside the contracts folder. So when I do npx oz deploy, OZ stands for Open Zeppelin, by the way. It's going to deploy all the contracts that I have inside my contracts folder. So let's just deploy right now. So I'm going to choose to deploy it as upgradable. So this is how easy Open Zeppelin makes it. I hope you remember how difficult it looked when I was doing it on Remix and doing it manually. So I can just choose to deploy it in upgradable mode, and that's it. So it does all the hard work for me. So I'm going to put on Goerli, pick the contracts to deploy. I'm going to select box, deploy the box contract. All the functions to initialize. No, we don't need that. That's an optional thing. So creating instance for the contract. So I'm just gonna wait. And meanwhile, we can go to Etherscan, and we can see all my latest transactions. And you can see that there's a pending transaction here that just got sent to the network. So I click on that. Just got deployed, and here's my new contract here. Etherscan is a great website where you can see all of the blockchain transactions and all of the history and everything. So, yeah. Okay, I don't know why it says that. Clearly deployed. Oh, yeah, good. That's weird. Well, if this doesn't work, we'll just do it on the Ganache local Ganache, the local blockchain. Oh, it looked like it worked that time. Yeah, blockchains can be finicky sometimes. I mean, there's a lot to know. Sometimes you don't know everything. So there we go. Interesting. Okay. So now we have deployed a contract here, and this is the contract address. So whenever we want to interact with the contract, we need this contract address. So I just deployed an upgradable contract. And when I deploy an upgradable contract, it's really a system of contracts. That means that there's one proxy contract that doesn't change, and then the logic contracts which can change. So now I can interact with the contract. So I can, here, this is a way to interact with the contract, npx oz send tx. So I'm just going to send the transaction, and it's going to ask me where I want to send it. So click network, Goerli, and I believe OXA9B. So this is, you gotta get used to this, like working with these contracts. I have to remember which contract I deployed before in this case. So it was this one, OXA9Bs, blah, blah, blah. So I'm just gonna select this one. So now I told the command line to send a transaction, and it asked me which contract do you want to send it to. So I chose the contract. Now it asks me which function do you want to call, because there's two functions. So I'm just going to call the increment function. Just so you see, there's two functions on the smart contract. There are indeed two functions I can call by sending the transactions. When I send a transaction, it only applies to the write functions. In kind of blockchain terminology, sending a transaction is what you do when you want to write a transaction, and calling a function is what you do when you want to read a value. So I wanted to write a value, so I called the send a transaction. So I'm going to do increment and write the blockchain now. What increment does is increment just increments this value by 1. So it seemingly did that. And now I'm going to do a call. So now I'm doing a call. So the call is for reading values. So let's just do that. Squarely, pick the right contract. To the right contract. And I'm going to call this retrieve function, which is view only. It's read only. I'm trying to read a value. There's only one read-only function, so I'm going to select that one. And I got the value 1. Okay. So the value of the variable is 1. If I do send tx again, and I call the increment function again, Lorally,
Excuse me, sir. Can you increase your font? Sorry to interrupt you. The font is not visible. Can you increase the font?
I'm sorry. Yeah, sorry. Yeah, thanks for your feedback. Is that better?
Little bit.
More? Yeah.
Can you increase it little bit? The font size.
Yeah. Is that?
And also there are few questions. Now it's visible, sir. Now it's visible.
Okay, yeah. So let me just run through this and I'll answer your questions.
Okay.
So I selected the contract, and now I'm going to store a value into the value. Let's just call it like 100. So now it's going to store the value 100. And so you can see, actually, every time I'm doing a transaction, it's actually doing, you can see it on Etherscan, because this is a public testnet. So I just made a new transaction, and you can see it here. Yeah, just wait for that to go through. Let's see if it went through. Yeah, sometimes it takes a little bit of time for the transaction to go through. It is a public testnet. If we were using the local blockchain, it'd be instant, but we're not, so it takes a little bit of time. So what was your question earlier? If you had a question. I was just going to call the value again. And then retrieve. That's going to show 100. So I'm just going to show you one thing now, and that's the cool part, which is to upgrade the contract. So I showed you how to deploy and interact with the contract using a command line interface. Kind of a basic but very important thing to do. Now, all you got to do is, all right, let's say we want to change the logic of the smart contract. And then you can just add a function that says increment by 2. And then just write it up. Value equals value plus 2. Value changed. So I just added a function. This is the Solidity programming language. So what I'm going to do now, I added this function. I want to upgrade the logic. And all I actually have to do is just type npx auth upgrade. So let's do that. npx oz upgrade. And as before, we're going to pick Goerli as the network. And then it's going to ask us which contract we want to upgrade. You choose by addresses, and we want to upgrade this one. So we're just going to upgrade it. So you can see how easy that was compared to the previous method that we failed at. Like I said, this is a really good tool, and it makes a lot of sense to use this. Yeah, okay. After this, we're just going to verify that it's been upgraded, and then yeah, I think it's got a few more slides I can go through. Yeah, I mean, this is kind of what I was speaking to earlier. Blockchain-based code authentication. You can build verification checks into the smart contract to make sure everything's proceeding as planned. So that's got to be really useful when it comes to DevOps. Again, there's not too many examples of that exist right now, but I believe it will exist very soon. So verification checks, important concept. And yeah, I mean, upgradable smart contract governance is something to think about for the future. When you are upgrading smart contracts, who has the permission to do the upgrades? Is it the developers? Is it the operations teams? Or is it a combination of the two? That's a question for governance, and that's something that's going to evolve over time, and something to think about. Who has authority over the upgrades? The good thing about smart contracts is that you can program it very transparently, very robustly, and it's not something you can tamper with. So yeah, I'll just go back here. The transaction is deployed. Now let's just send the transaction and make sure that our new function is usable. So we created a new function called increment by 2. So that's going to show up, hopefully. Yeah, a little bit of a delay there. So this contract down here. Yeah, so now the new function is showed up. We've successfully upgraded the contract, and now there's a new function and new logic that's available. So we're going to call that function, and then we're just going to see what the value is after we increment it by 2. First, we set it to 100, then we increment it by 2, so the value should be 102. Just going to wait a few seconds. But yeah, for the rest of the presentation, I'm just going to open it up for questions, and anybody who has questions, please be very welcome to ask your questions. I love your questions. Let's see, upgrade call. Let's call this Goerli. Yeah, actually, we can see that there was an event emitted and the value is indeed 102. So we don't actually need to verify anymore, but let's do it anyways. Retrieve. So the value is now 102 and everything worked out. So yeah, anybody have any questions now?
Sir, in chat box, there are questions from the participants. Sir.
Oh, in the chat box, got it. Okay, sorry for not increasing the font earlier. That's my mistake. The tools, all the tools are open source. Like all the tools I showed you, fully free, open source. It's quite amazing. Okay, so how do you run a Solidity program? Yeah, there's multiple ways. You can run it using sorry, where is it? Open Zeppelin CLI, right? So this tutorial actually goes through how to compile and how to deploy and how to run a Solidity program. So if you go through this, it will show you everything. And it's not rocket science. It might be tricky for you at first, but you can definitely do it. The other way to compile and deploy Solidity programs is through Remix. So you can use Remix. You can write your code in here, compile it here. You need to install MetaMask for this. But once you have MetaMask, you go to inject Web3, and you can deploy your contract like that. So, and then it's going to come up with a transaction box to deploy it. So there's multiple ways to run and to compile and deploy Solidity contracts. There's Remix. There's Open Zeppelin, and there's a number of other methods. So Remix is great just for like testing stuff out, doing simple stuff. This is better for doing like bigger projects. But to be honest, it's not really difficult for small stuff either. So yeah, I recommend trying this out, Open Zeppelin. Okay. Let's see, I'm going to stop presenting right now. Open same idea, something program, you know how to run. Yeah, so for Remix, actually just look up videos on YouTube. That'll show you how to do it. If you want to run something on Remix, you need to download MetaMask. You have to go to metamask.io and install MetaMask and the browser extension and set up a wallet. So that's the first step. Get MetaMask. After that, yeah, there's some tutorials out there. There's some good videos on YouTube. It's not too difficult. It's just like you have to know the steps. So that's why it's good to watch the videos. Screen. Okay, sorry I didn't make the screen bigger. I wasn't paying attention, and thank you for letting me know. Okay. Is there any other questions anyone has? If not, I'll just go through here. We actually have a hackathon coming up. It's an online hackathon. Everyone's welcome to join. It's a great way to start learning blockchain. Just go to this link here. I'll paste it in the chat. And then if you join this meetup page, you can get updates about the hackathon. And so join that if you're interested in joining hackathon. We've also developed a bounty platform as well. It's called the DevCash Bounty Platform. It's designed for developers to come and earn cryptocurrency by doing developer tasks, and for people to post bounties. So you can think of it as a sort of decentralized Fiverr with cryptocurrencies for developers. So bounties are, it's basically you get paid to do tasks, or you can pay people to do tasks. So if you're interested in trying that out, go to this website and give it a shot. I'm gonna link there. And finally, if you would like to contact me, I do offer lessons. You can just contact me on Discord or my email. Or if you have any more questions, feel free to just send me a message. I'll answer your questions, no problem. So, yeah, that's it. If anybody has any comments, feel free to say them. If you liked my presentation, if you didn't like my presentation, good feedback, bad feedback, any feedback is good feedback. So I hope you enjoyed it, and I hope you learned something. If you'd like to know more, just email me here. I put my email here. And that's it. Hope you enjoyed it, and I hope it was useful. So, yeah. Anyone interested in training how to become a blockchain developer?
Hello.
Hello.
Yeah, Antoine. I was wondering that, are there, do we need to use the tools, the other DevOps tools like Jenkins, etc., while also using Truffle side by side? Or does Truffle take care of everything, don't require any other tool?
Truffle definitely does not take care of everything. The problem is the integrations between Truffle and Jenkins. As far as I know, I don't know how to integrate them right now because it's sort of early days. But Truffle does not take care of everything. And to be honest, the tools to fully integrate smart contracts into the DevOps don't exist yet. I mean, I imagine the existing DevOps, the popular tools will integrate smart contracts at some point, and the blockchain tools will grow to encompass more DevOps capabilities. But right now, no, they're kind of a little bit separate right now, and you have to know what you're doing to put them together. At least on the smart contract side. And I will say that it's not too difficult to master smart contracts. You can do it. And if you master smart contracts, you can integrate them into your DevOps pipeline yourself. I personally think it's harder to master DevOps than it is to master smart contracts. So once you've mastered DevOps, it shouldn't be too hard to add smart contracts in.
Okay, now what the Truffle and all this you have mentioned is related with Ethereum platform. What about the Hyperledger or other blockchain platforms? Whether those can be managed with the other DevOps tools like Jenkins?
You're saying they can? I'm actually not sure. Can they be? I think there's some of those enterprise blockchain frameworks have support from Microsoft and that kind of thing. So they probably integrate a lot better with Microsoft tools.
Okay.
Also, there's probably some DevOps integrations into Azure and blockchain, but I haven't explored those too much. And they're not as widely used, at least in the blockchain world, as Truffle is. There's not too many people in the blockchain world using Azure, or at least in the open source blockchain world. Yeah, I don't know everything about those tools, to be honest. But what I said about Ethereum, like the general principles, can apply to other blockchains as well. So all those things about governance and transparency and all those things are applicable to other blockchains as well. But that's something to explore about integrating those tools, yeah, into your DevOps pipeline.
Yeah, okay. So actually there was one missing piece, that is, the actual, any demonstration on Solidity and, the Ethereum platform tools was actually not covered in this course prior to your session. So, I mean, I will leave it for Dr. Tigre and Atul Marathe to decide whether a short description about the basic Solidity tools and the smart contracts should be covered in the remaining 30 minutes.
Yeah, I mean, I think that's important when you're talking about smart contracts. You should show examples of smart contract code, Solidity or other code, and that should be there. Yes, you have a question? Okay, well, it's almost...
Okay, yeah, so Atul, you please decide. Is Atul online? Okay, Tigre sir, it's your...
Yes, sir.
It's your call.
Yes, sir.
It's your call whether you would like to utilize the remaining half an hour for just a quick overview of Solidity and the basic smart contracts development.
Okay.
Or
Or
I can do that.
Before that, can we have questions from the audience?
yeah, that's better. Absolutely.
So participants, any questions so far, whatever sir has demonstrated? Any doubt regarding that? Any question? We have a time up to 7, sir. So we can utilize, almost half an hour is there. We can utilize it for remaining part.
Okay. So Antoine, would you like to quickly just explain the basic concepts of Solidity, Remix, the creation of smart contracts, and that aspect,
Yeah, so I can go into that. This will, Arun Kumar was asking about how to do Solidity contracts in Linux, and I guess we can just do that. Yeah, sounds good. I'll deploy this, show you how to code a smart contract and deploy it. Let's go here. Oh, wait, let me show my screen. Hold on. Yeah, that. Okay. So let's get rid of these ones. We'll just start a simple contract. So, all right. So let's say you want to write a basic contract for practice. Actually, anybody who wants can follow along and just go to remix.ethereum.org and follow along and try and do what I'm doing. So yeah, actually the first thing you need to do is install MetaMask. That is the first step in this particular way of performing smart contracts. So what I'm doing here is I'm just going to show you like an easy way to deploy smart contracts and just an example of Solidity code. So here is my the first thing you need to do. The first thing you need to do is declare the version. Let's check what the latest version is. The latest version is Solidity version 7 already. So I'll just do 7.0. That is the version. So let's say I want to create a contract now. How you define a contract is you just go contract text, or whatever you want the name of the contract to be. No brackets. Well, let's call this instead of test. Let's call it just you know, like mood. Okay, so get inside your mood. So let's call let's say we want to make a variable that represents my mood. So I'm just going to make a string here. String mood. Oh, and I need to make it public because when you make it public, it means that anybody can view it, and anybody can see, can read the value. So now I just want to make a read function and a write function. And by the way, I have a tutorial on how to make a decentralized app. I can share with everybody. It's pretty much what I'm showing you now, but it also includes a front end. So here is the tutorial, and I am just going to share it here. So if you go to that tutorial, you can learn how to create a decentralized app on Ethereum. And it is very hands-on, so it will show you step-by-step how to do it. And I highly recommend doing this if you want to learn how to do app development. And don't be discouraged. You don't need to be a genius to be able to do it. It's not rocket science. Maybe tricky here and there, but you can definitely do it. So just click on that and do the tutorial whenever you get the chance. But let's go back to Remix. So I'll put a mood here, and I'm going to say declare a function. What are we going to do? We want to read the mood. So we're going to say function is called read mood. And it's going to be a public function, and it's going to be view, which means it's read only. And it's going to return a string. And then we just put the curly brackets like that. Oh yeah, string mem, you have to call it memory because it's not a storage. Like in smart contracts, you have memory and storage. Storage is when things are stored on the blockchain. It takes up a lot of gas. Memory is when it's just sort of a variable that's stored in memory of the smart contract while it's executing, but it's not stored on the blockchain and it's not readable afterwards. But what we're going to do here is, sorry, it's just going to return the mood. So just return mood. That's it. That's how you write a function that reads a value. Now, actually, technically, you don't even need to have this function. You just have this public declaration here. It means that this will automatically be readable in the same way as if you had a function. It's automatically going to create a getter function called mood. But we'll leave it there just so it makes sense. And the next function is going to be a setter function. And it's going to be to write a value to blockchain. So we're going to say the function write mood. For this, we need to pass it a parameter. It's like, how does it know what mood to write unless you tell it a mood? You give it a mood to write. So I'm going to say, when you call this function, you need to give it a string. ASCII memory again. And then all you do is just mood equals food. And that's it. That is our simple smart contract. Very, very simple. Okay, so if you have MetaMask installed, if anybody's following along, you need MetaMask. Let's go to the Robson testnet because it's easier to get Ether. So when you go to the Robson testnet, you have to get testnet Ether, right? So if you just click the buy button here, and you go to the test faucet. You just go to buy test faucet, faucet.metamask.io. Wait for that to load. Oh, mounting it down. Weird. Unix and the faucet went down at the same time. Okay, so in the faucet, you can just click this and it'll automatically send you some testnet Ether. Oh wait, no, sorry. Click this one. And you will get some testnet Ether. It's not worth anything, but you still need it to do transactions and stuff on the testnet. So let's go back to mood. What you got to do is you got to make sure you have the deploy and run transactions and the Solidity compiler. If it's not there, you have to go into plugins and get it. Search for the compiler, search for deploy and run transactions. It should be there automatically though. And you just here on the environment, you have to select injected Web3. So Web3 is being injected by MetaMask. If you remember back in my presentation, you remember this slide right here. Remember how our wallet connects to the front end? That's what Web3 is all about. So the front end makes a Web3 call to the wallet. So the wallet and the front end are connecting together through Web3. And the wallet's going to connect with the blockchain, and the blockchain is going to connect with the app as well. But so that's why it says injected Web3, because it's connecting to my MetaMask through Web3. MetaMask is my wallet, and this is the app. So make sure you're on injected Web3, make sure it's compiled, and you can just deploy like that. Click the button, one click, deploy. And confirm. And then you can go and see that the transaction has been confirmed on the Etherscan. You can see our activity here. There's a little out button here. You can see directly the Etherscan. And let's just check if there's some regular transactions. Yeah, all right. So it's being deployed. So yeah, it's a contract called test. I can do two things. I can either read the mood or write the mood. Like I said, yeah. Oh yeah, okay. So like I said, I have a read function and a write function. When you put public here, it automatically creates a function. So there's a function called mood as well. Technically, I didn't need this one, but put it in anyway. All right, so I can, right now the string is empty. So I'm going to put my mood, I'm going to say relaxed. And write it with the transaction. It's going to write the string to the blockchain. So wait for that to go through. It went through. You can see the transaction here. And yeah, relaxed. It worked. I read the relaxed. And yeah, that's how you deploy a basic smart contract on Linux. It's pretty simple. So let's see, any comments? No? Yeah, so if you go to tutorial here, you can learn how to do that in a full deck. Now this is without getting too complex in the Solidity contracts. We can go a little bit more into Solidity contracts right now. But this is basically the same contract you deployed, right? Yeah, get mood, set mood. But it actually teaches you how to create an app, a web app, which connects to the contract. So you have a fully functioning decentralized app at the end of this tutorial. So do this tutorial. You'll be a blockchain developer after you do this tutorial. Okay, so you go back to Remix. You can do a little bit more complex stuff. You can declare an integer. Call it like, I don't know, let's call it age, something random. You know, you can read age and you can write age too. You know what I mean? Read age. And instead of string memory, it'll be uint. Just showing you some examples here. Turn age. Instead of string, it'll be uint age. All that, make sure there's no errors. Yeah, you can do all sorts of different variables. You have string, you have uint, you have bool. I don't know, just saying, just putting some random stuff here. Am I awake or am I asleep? We have, so bool it means true or false. We have bytes 32 is a type of variable, which is like a bytes object, represents a mathematical, it's kind of like a number, basically, but just in a certain format. What else we have? Yeah, those are some of the main variables. Let's see. Yeah. Bytes. Oh yeah, address. Address represents Ethereum addresses. So that's a very important variable type as well. Is address. So this is an address right here. So I could just go like assign the address directly if I wanted to. I'm sorry if it's not big enough. So this is the address right here. This is what Ethereum addresses look like. Yeah, you have to get used to it. Oh, and the addresses are just a number as well. These are it's just a number in a certain format. So I mean, these are all numbers. Like the address is a number, a hash is a number, so uint is a number. They're all just numbers in different formats. Yeah, there's no such thing as decimal really in Solidity. Everything just works in integers. There's no, yeah, everything works with integers. Or you can also do int as well. Int means it's like a uint, but it can go into negatives. Uint cannot go into negatives. And then there's also a variable type called mappings. You can do address. For example, I don't know, balances. Mapping is basically a map of one variable to another. So this will just create a list of addresses that are associated with certain integers. You can map any variable type to any variable type. So you can map addresses to addresses. You can map addresses to place32. You can map addresses to strings. Or you can even map addresses to another mapping. I know that seems kind of confusing right now, but it makes sense, trust me. So we want to do something more complex. We also have events. So event, move, written. That's basically something that allows you to log things that happen. So events are good for when you want to just put a little piece of information out there on the blockchain, but it's cheaper than storage because you're not putting it in a variable it's not a variable, it's just a log. So it's not something that you can alter. It's just something that's just written to the blockchain one time. And it's pretty cheap to do. So you can put like a string or a uint or the string mood. So every time someone writes the mood, it's gonna log an event saying this mood has been written. So you can say mood written. Oh, sorry, not here. Oh, sorry, yeah, you have to put emit for events. Yeah, so yeah, there's a lot you can get into in Solidity. It's not endless though, like eventually you'll master the whole thing. There's a lot of quirks though. Something funny you can do, a bit of knowledge for you. You can basically sort of hack Solidity. It's not really hacking, but you can get around all of the limitations of the syntax by putting assembly code. Basically, very low-level language where you can do things that are not possible within the constraints of the Solidity language. Yeah, you don't need to understand all this, but basically, it uses opcodes, which are low-level calls, and low-level stuff that you can do a whole bunch of different stuff with. But sometimes you need to use it because there's something you need to do that's not possible with Solidity. So Actually, this was required for the upgradable contract. When we were deploying upgradable contracts with OpenZeppelin, it's deploying contracts that have assembly ready. Because when you're doing upgradable contracts, you have to do some funny stuff that, yeah, it's a little bit finicky. You can't really do it with regular Solidity. So, like I said, you can master Solidity pretty easily, but then when you get really deep into things, yeah, you can use assembly to do pretty much anything you want. Like, it's pretty much programmable to do absolutely anything that a computer can do. It's Turing complete, as they say. You can program anything you want. Yeah. What else? You want to know more? What shall I? Yeah. So yeah, you can, once you added your code, you can just deploy it again, compile it again, deploy it again, and you have a new contract. If there's a bug and you deploy it, then you have to deploy a new contract to fix it. You can't fix the old contract. That's why the upgradable contract systems are so important. Yeah. Oh yeah, let's show some, as a final thing, some permissions, right? Let's say I wanna make this contract so that only I can edit it. So only I can set the move. So I'm just going to do this in a basic way. I'm going to say address owner equals me. So I'm the owner. I set a variable called owner, and I made it me. So when I write the mood, I can put a little statement here that says message.sender. Message.sender is the address that's calling this function. So if I call this function, message.sender will be me. So if I put this, require message sender equals owner, then let's try and deploy this. So what should happen is that when I call it with my address, it should work. But if I call it with a different address, it's going to fail. You can create a new address here in MetaMask. You can have multiple accounts. Just send some detail over here. Some kind of bug. All right. So yeah, let me just try and change the mood right here. My mood is sleepy. I'm gonna write the mood. Looks like it's working. Let's just wait for it to confirm. Then we'll check the mood and see what it says. Right now it says nothing because I deployed a new contract. So okay. So now let's read the mood. I can read the mood from any address. So I'm on my second address now. I read the mood and it says sleepy. So now I'm a hacker. I'm someone who wants to change the smart contract and steal some money or change some information I'm not supposed to change. So I'm gonna put like awake, super awake, and I'm gonna try and write it. Oh, guess what? I'm not the owner, so it didn't work. I don't have the permission. The only way I can get the permission is if I get the private key for this address. I somehow steal a private key. But I can't really do that because I can't guess the private key because it's such a long like string of numbers and letters that it's pretty much impossible to guess. The only way to get it would be if the original owner gave it to me, or if they somehow left it exposed, or if I somehow stole it. So the lesson is keep your private keys safe. Don't let anyone take them. If they take your private keys, they can mess with your permissions. If they don't have your private keys, there's pretty much absolutely nothing they can do. So that's one example of how you can do permissions on a smart contract. Yeah, you can just use this require statement here to sort of block any conditions you don't want. So it's going to have to pass this condition before doing anything else. It's a great way to program smart contracts. You can also use if statement. Do the same thing. If message sender equals owner. So yeah, I think that's it for today. And I hope you enjoyed it. If there's any more questions, please feel free to let me know. That was fun. Thank you, everybody, for attending.
Yeah, Dr. Tigre, you can open up for questions, and if there are no questions, we can close.
Yes, sir. Any question there at this moment?
Okay. If you would like to contact me, I put my email in the
yes, sir. We are going to share that all parts. No issue, sir.
Okay.
So on behalf of Sir SVERI family, Computer Science and Engineering Department, and being as a coordinator for this, it's my great pleasure. I will not say thanks because I don't want to be saying thanks and getting disconnect with this part. It's really great to have an interactions with you. The way you have demonstrated this all parts, it's really a great, sir. So thanks.
Oh, thank you. I appreciate it. And it's really
and only one request from my side. It would be better if you share some study material on that part. Some links and this, so that participants, we will share it with the participants and they can have hands-on on the same.
Oh, I'll send some links to Ashok, and then you can pass
okay, no problem. I will collect from Ashok, sir. No issue, sir. Thank you, sir. Thank you very much.
Thank you. And I really appreciate everybody coming, and I appreciate participating in this. It's, yeah, it's very, very amazing. Thank you.
Thank you. Thank you.
Okay.
Thank you, Mr. Anthony. It was a nice session as such. Mr. Suhas Deshpande. Mr. Anthony, it is a nice session you have done. Thank you. Thank you very much.
Thank you, Suhas, sir. Thank you.
Okay, thank you. Bye.
Ashok sir, चांगलं झालं. Ashok Randre sir, चांगलं झालं session. Very good. Appreciate it.
We'll meet tomorrow exactly at 2 p.m. on blockchain.
Sure. Thank you.
Okay.
Thank you.
Thank you all. Thank you. Thank you.
And good night.
Good night. Good night.